Hi folks, this is Nat, and this is going to be a video lesson on evaluating algebraic expressions with integers. So we've already covered both these concepts, so we'll just be putting them together as well as combining them a little bit with the concept of order of operations. An algebraic expression, if you remember, is typically an expression that includes a variable. Integers obviously are positives and negatives, and what we're going to be working on is evaluating them, which means finding their value, which is in a lot of ways synonymous with solving. So this should be a pretty quick one. I'm going to give you a couple examples and go through some of the mistakes that students sometimes make, particularly when it comes to integers. But let's just make sure we have a sense of evaluating algebraic expressions. So here I've got the algebraic expression m plus 3, and I'm going to evaluate it first if m equals 2. And what that functionally means is I'm going to take that value for m, 2, and plug it right back into that expression, replacing the m with a 2. So if m has a value of 2, it's okay to swap that out or substitute it. So I'm going to say 2 plus 3 is how that substitutes out. And if I actually evaluate that, 2 plus 3 is 5. So that's a pretty easy one. I've swapped the m for its value, and then I've evaluated. Here's another one. Same expression, but in this case, if m equals negative 8, same thing. Well, it's m plus 3, so that's the same now as negative 8 plus 3, which I can go ahead and solve. The big thing here is to just keep my rules about negatives and positives in my head. When I'm adding them together or combining a negative and a positive, they cancel out. So they're going to cancel out up to a point, and I'm going to be left with negative 5 because negative 8 was the larger value to start with, and they have a difference of 5. So that m plus 3 would evaluate to negative 5 if m is negative 8. So that's basically how evaluating expressions works. And it's not overly complicated, but it does get a little more complicated as we go along once we kind of start thinking about how a lot of the negatives and positives interact with one another. Here I've got 7 minus 3f, and I'm going to start with if f equals 7. So as a quick reminder, if you didn't know this, when I see this coefficient, that's when a number is sitting next to a letter, that is a math way of writing multiplication. So this is 3 times f. So when I start substituting stuff in, I'm going to substitute it in as multiplication. A common mistake is to substitute in like this, and people just write the number next to it. So if f is 7, they'll write 3, 7, and maybe they know that that's multiplication, but it's going to get them confused, and they're going to think in a minute that it's actually 37, which it's not. So make sure you kind of note to yourself that that's 3 times 7. In one of those ways, we write multiplication. So let's start with this easy one, if f equals 7. So 7 minus 3f, and since f has a value of 7, I'll write times 7. Easy enough. And now I need to remember to evaluate this according to order of operations, which is, as we've talked about, parentheses, then exponents and roots, multiplication, division, addition, subtraction. There are no parentheses, there are no exponents or roots. We're going to start with our multiplication. 3 times 7 is 21, and typically I'll just rewrite the rest exactly as I originally saw it. So 7 minus 21. Again, I have to follow my kind of negative positive rules here. When I say 7 minus 21, I'm taking away more than there is, or I might think of it as I'm adding negative 21. I'm combining negative 21 and 7. So obviously there's more negatives, more being taken away. The difference between those is 14, and since more was coming out, I'll put a negative sign on there. So 7 minus 3f evaluates to negative 14 when f equals 7. Let's go back and do this again now for the second value of f. So same deal, 7 minus 3f, except this time f has a value of -9. When I insert a negative, a nice habit to get into is always insert it into a parentheses like this. And that'll kind of make more sense in a minute why that might help you. In this case, it helps me because I might recognize right away that this is not subtraction, this is not, 39. This is 3 times -9, and same thing as before, I'll evaluate that part first. 3 times -9, that's -27. And it's really easy to make the mistake of forgetting that this minus sign is here. Because really what we're going to do now is bring that down, and it's going to be 7 minus -27. Which, if you remember, subtracting a negative is like adding. So this is really like 7 plus 27, which is going to give us a total value of 34. And there's actually another way you could have done that. Let me show you. Let's back it up a little bit. Way back at the beginning, remember it's always okay to think of -3 as being -3. So if the very first thing I'm doing is multiplying 3 and 9, I could actually include that negative sign in there and say it's -3 times -9. If you remember your rules for multiplication, negatives cancel out, so that's going to end up being positive 27, so 7 plus 27. When we put those together, you might notice that it gets you to the same answer. So you're always more than welcome to kind of include negatives together or minuses together, but you either need to make sure that you include it like we've done here, or alternatively, when we did it the other way, you need to remember that if you don't include it, you have to keep it. So this is 7 minus -27, and they end up being the same thing. Either way you do it, but you do have to pay careful attention to that minus and what's happening to it. Let's take another example. All right, so here we've got two variables, but it really is exactly the same thing as before. We've got q to the second power minus 4f if q is -4 and f is -6. So the first thing I'm going to do is swap things in. So q has a value of -4, so I'm going to put that in for the q, and I'm going to put it in the parentheses. And that's really important, because I'm going to square that whole -4. If I had written it this way, if I was actually following order of operations, it would imply to me that I was just squaring the 4 and tacking the negative sign on afterwards, which is not what I'm actually going to do here. So we do want to insert it in the parentheses, and then we want to subtract 4 times f, or 4 times -6. And again, I'm going to insert that in the parentheses. Then I can start evaluating according to order of operations. None of these parentheses really matter. I can include these in here if I wanted to. That's fine. I'll do that first then. 4 times -6. Hopefully you remember that's -24. Again, it's important to recognize that this negative sign, or this minus sign, I guess I should say, has not gone anywhere. So I'm going to bring that down, and then -4 to the second power. Now I'm ready to do my exponents. This is -4 to the second power. That's -4 times -4. Two negatives cancel out, so that's going to be positive 16 minus -24. Again, when I take away a negative, it's a lot like adding, or identical to adding. So I'll finish up with 16 plus 24, and this expression evaluates out to 40. All right, one more example, and we'll let you practice. So same idea. There's really a lot of just repetitive stuff here. So long as you kind of get yourself into good habits, you shouldn't find that you have too many problems. I'll start by substituting in W. Everywhere there's a W, it's going to be a -4. Again, -4 in parentheses will really help me out. So 9 plus -3. Here's my W, so I'm going to put in a -4 instead of the W to the second power divided by the square root of 40 plus, again, -4, not W. All right, now I've got a lot of order of operations stuff to think about here. So sometimes it's nice to write it down and check it off as you go. See, parentheses. Anything under a root is like a parentheses. So I'll do that first. 40 plus -4. Well, negatives cancel with positives, and I'm going to end up with 36 there. So this is really the square root of 36, and then I like to rewrite the entire thing. It might take a second, but it'll keep me from making mistakes that I might otherwise make. So 9 plus -3 times -4 to the second power divided by 36. I've done my parentheses. I'm going to do my exponents and roots now. Well, -4 to the second power, we did that on the last problem. That's -4 times -4, or 16. So let's start rewriting. 9 plus -3 times 16 divided by the square root of 36. Well, I'm on roots, so I might as well do that. 36 square root is 6. Okay? Moving on, I'm ready to do multiplication and division. Now I'll do them in left to right. So I'm going to start with my -3 times 16. I remember my rules: a negative and a positive make a negative, because there's no negatives to cancel out. So I'll start rewriting. 9 plus -48 divided by 6. And I've kind of run out of room, so just for the sake of being able to see this, I'm going to grab it and move it ideally. Let's see if I can manage that. Okay. Let's put it, I don't know, right here, and we'll see if we can finish up. Okay. So I'm still on multiplication division. So I needed to do -48 divided by 6. Same deal as before, only one negative. 48 divided by 6 is 8. Since there's no negative to cancel out this negative, it'll just stay negative, -8. And I'll rewrite the rest. 9 plus -8. Getting a little messy here, but we're basically done. 9 plus -8, my rule says that negatives cancel each other out. So when I add -8 to a +9, I'm left with 1. And that is my final evaluation. So just keep a close eye on those negative signs. Always insert those things in parentheses. It'll save you some trouble. This shouldn't end up being too difficult for you. And here are a couple practice problems to get you started with it. So evaluate those 3. Good luck.